All right, we're going through 2024 AP CS A FRQ. First problem is this feeder class. So this question simulates birds or possibly a bear eating a bird feeder. The following feeder class contains information about how much food is in the bird feeder and simulates how much food is eaten. You will write two methods of the bird feeder class, and the first one is simulate one day, and the second one is simulate many days. Okay. So you have your current food, the amount of food in grams currently in the bird feeder. Initializing the constructor always greater than or equal to 0. Simulates one day with numbers, or simulate one day is simulate one day with numbers, birds, or possibly a bear at the bird feeder as described in part A. Okay, so write the simulate one day method, which simulates number of birds or possibly a bear at the feeder for one day. The method determines the amount of food taken from the feeder on this day and updates the current food instance variable. Simulation accounts for the normal conditions, which occur 95% of the time, and abnormal conditions, which occur 5% of the time. Under normal circumstances, the simulation assumes on any given day only birds visit the feeder, and each bird at the feeder consumes the same amount of food. The standard amount consumed is between 10 and 50 grams. So it seems like I'm going to create a random number between 10 and 50, but I'm going to multiply it by the number of birds because they say they all have that standard amount. On any given day, each bird might eat 10 to 50 grams. The amount of food eaten by each bird on a given day is randomly generated. Yeah, okay. A run of the simulation might predict that for a certain day, under normal conditions, each bird coming to the feeder will eat 11 grams of food if the 10, okay. Contains 500 grams. The call simulate one day could result in 12 birds eating 20 grams each. All right, simulate one day. So okay, so we have our current food as well. So we want to have a random occurrence equals math dot, and it's not an int. We could make that a double. You could cast it to an int, but I guess you don't need it as a variable, but that's fine. So you would say if ran occurrence was less than 0.5, 0.05, because this can get a random value between 0 and 0.9 repeating. And so 0 up to 0.049999 would be 5% of the time. We set our current food equal to 0. Else, that's 95% of the time, birds come. And we need to, this is where we need to get a random number. Ran amount eaten equals int math.random times the range, which is 41, plus 10. Plus 10 makes the minimum 10, and math.random times 40 gets a random number 0 to 40, plus 10, 10 to 50. So that's your random amount eaten by all the birds. You take that ran amount eaten and you actually do current food equals minus equals ran amount eaten times num birds. You don't need parentheses there, order of operations. Let's just make sure we got that. Okay. I would say you don't want current food to ever be negative. So if current food is less than 0, current food equals 0. Okay. $12 birds, number of birds eating 20 grams of food each. 260, yes. 1,000 grams of food, 22. A bear eating all the food, so that's the 5% of the time. Current food is 0. I think that's good. So if we go to the answer key really quick, double check our answers here. Yep, 5% of the time, current food is 0. Oh, they did do that and set it as a variable. Else, mathed out random, yep. Total eaten. Okay, so they, maybe a better way to do it, but they had a variable that was stored when you multiplied numbers by amount eaten. Mine was ran amount eaten, but yeah. If it's greater than current food is 0, else you do the subtraction. I kind of just did the subtraction, and then if it was less than 0, set it to 0. Otherwise, it would stay the same. So that works. Write the simulate many days method. That the method uses simulate one day to simulate number of birds or a bear coming to the computer or number of consecutive days. The simulation returns the number of days that birds or bear found food at feeder. Okay, so all right, so this will be the number of simulations that you're trying to have. This is the number of birds. Let me double check. Yeah, number of birds. And then we're going to count and return the number of days. So it could be 4 if it makes it to the end. But we could run out a little bit early and return a value of 2. All right. So public int simulate many days int num birds int days. All right, so we want to loop through days. And I'm going to have my I value start at 1 and be less than or equal to days. So I is a true, it is the day. So actually I'll change it to day is less than days. So this will be the day that we're on. So we need to call simulate one day. Num birds is going to match. So we'll pass in whatever value they plug in here, like a 10, and it'll pass into here as well. So you simulate it. So current food is what I've been using. I hope that's right, that is an instance variable, yeah, that we can have access to throughout the entire class. So we could just keep using that. If current food equals 0, we are going to return day. And then if we make it to the end, day, we can return days because we know we made it all the way to the end. So I don't know if there's a different way of doing this, but basically I'm looping the number of times they're asking. I'm simulating a day, and if my current food ever reaches 0, I'm stopping this whole method and returning which day we are on. So to me that makes sense. Let's look at the answer. We loop through, days so far. If current food okay, so they simulate after, making it so that they can start at 0, and they check if the current food is 0 before they simulate one day. I start at 1 and I simulate right at the beginning. Maybe that doesn't handle if there is 0 food in the feeder. I don't know if they have that as an example. I didn't read slowly enough. Yep. So I did not read, and this is something you guys need to be aware of. Okay, you can miss a point just by not focusing on what the question is and trying to go too fast. And I'm trying to demonstrate it, but like I said, I checked this. After the fact, I guess, but I think I would have checked it if I was reading through. You should look at all of the examples because they usually add in each example for a reason. To show you something. And this example would say, well, if current food starts at 0, you should return 0. Now, does mine do that? I don't think so. Because since my day starts at 1, I simulate first. So I could just put if current food, it starts at 0, I could return 0. I could do that, or I could do it how they did it. By starting at 0, to me that doesn't compute as well in my head. So I would probably put this outside. All right, that's number 1. Number 2, the question involves a scoreboard for a game. The game is played between 2 teams who alternate turns so that at any given time, one team is active and the other team is inactive. During a turn, a team makes 1 or more plays. Each play can score 1 or more points, and the team's turn continues, or the play can fail, in which case no points are scored and the team's turn ends. Scoreboard class, which you will write, is used to keep track of the score in a game. The scoreboard class contains a constructor and 2 methods. The constructor has 2 parameters. First parameter is a string containing the name of the team 1, and the second parameter is a string containing the name of team 2. The game always begins with team 1 as the active team. So, what would be our instance variables is what the first thing we should look at when we're talking about the class problem, right? And actually, just quickly to go back to the number 1, you'll see in number 1, it's the methods and control structure. Almost always, you're going to be looping through something, and you'll be utilizing an if statement and utilizing a method call. So here's our for loop, here's our method call, here's our if statement. In the original, they didn't use that, they just used if statements. But there's a variety of questions, but you should expect that most, either part A or part B, will have a for loop, method call, and if statement. So if you didn't know anything else, you should know that that will happen. So back to number 2. So on classes, this is the class problem. You need to know instance variables, constructor, getter setter methods, or a generic method that they might ask you to do. And so the constructor, a scoreboard for a game, you're probably going to have team 1 points, team 2 points, and it says they have team 1 name and team 2 name. At this point, that's all I can see. The record play method has a single non-negative integer parameter that is equal to the number of points scored on a play, or 0 if the play failed. If the play results in 1 or more points scored, the active team score is updated and that team remains active. If the value of the parameter is 0, the active team turn ends and the inactive team becomes the active team. The record play method does not return a value. The get score method has no parameters. The method returns a string containing information about the current state of the game. Okay, this is going to be your holy grail of information on how to do this assignment. So, constructor, string info. Okay, so that's going to be the information about your game from get score. Okay, so I'm going to create a new file. Whoops, .java is what I meant, but that's all right. Okay, okay, string info, string team1 name, string team2 name, int team1 score, int team2 score, public scoreboard, string team1 Okay, so I got those down, pretty straightforward. Red and blue, info.game.getScore, put the scores, game.recordPlay1. So, team 1 earns 1 point because the game always begins with team 1 as the active team. So they never said that in the instructions. So sometimes you have to read through you definitely should read through the explanations in this table that they'll always have for these problems, or almost have always had. So, okay. So it says record play as a void method. So I guess we need to keep track of team's turn, whose team's turn it is. And I'm going to use a int value that is set equal to 1 maybe, and say if team's turn mod 0 equals 1, we are going to look at team 1. Okay, so record play. They don't give you a ton of information in this there. You need to look here. Single non-negative integer parameter that is equal to the number of points scored on a play, or 0 if the play failed. So, gotcha. So actually that makes it a lot easier. Int points scored. Team 1 score plus equals points scored. Else team's turn, else team 2 score plus equals points scored. Okay, so the value of the parameter is 0, so we need to utilize that. So we start as team 1 if points scored equals 0. We just say our team's turn will ++, and that will change it from odd to even or even to odd. All right, so we have the record play method, I think, entirely done there. So then get score is our other part. Get score returns a string of the current situation. So we need to have that. All right, so team 1 dash team 2 dash winning team. All right. So, or team in the lead. Public void get score, and that's going to return a string actually. If team 1 score is greater than team 2 score, we are going to return team 1 score plus quote dash plus team 2 score plus quote dash, no spaces, red. Oh, it's whose turn it is. Yes, whose turn it is. Okay. Is that right? Get score method of no parameters method returns a string containing information method. The return string begins with the score of team 1, hyphen, followed by score team 2, followed by a hyphen, followed by the name of the team that's currently active. Whoops. So if, well, we could say active team equals team 1 name to start, because that's what it is by default. If team's turn mod 1. Oh, why did I do mod 0? Mod 2 equals 1. Mod 2 equals 1. We'll say we'll move this down. Goodness gracious. Set our active team equal, if it's divisible by 2, to team 2 name. So by default, active team will always start off as team 1. If it's team 2's turn, it'll switch to team 2. Then we'll do plus hyphen active team. Okay, I believe that's it for the scoreboard. Yes? So, first off, all these variables need to be private. You need to make sure you memorize that, you write it down in a note. I am really bad at remembering to do that, but it's not that it has to be done. It's that, well, for the AP exam, it does have to be done. But in general coding, it's just good practice to do it. You're supposed to. And then your other question was initializing these variables up here versus in the constructor. If you create a variable, declare it in the constructor, it's only local to the constructor, so you don't have access to it outside of the constructor. So you want to make them up top because we're using them throughout the entire class. Yeah. Shouldn't it be what? Yeah, technically, yeah, you should initialize all of your instance variables. If they're instance variables, they will be set to their default value, which would be 0, but it's good practice. In the constructor, the job of the constructor is to initialize instance variables that have not been initialized yet. So, yes. Okay. All right, so let's take a look at what they did. Those are good reminders. I would have lost a point for not having private there. So another thing, don't rush that part either. So private, team name, team 2 name, private, whose turn, private, int, score 1, score 2. Initializing all of those values in the constructor as you should. Record play. If points is 0, if it's team 1, switch to team 2. If it's team 2, switch to team 1. Yeah, I just have it as a plus plus. Else, add to points. So I would add, on mine, I added 0 points when it was 0, and then I just did points plus plus. So I don't know if you guys noticed that, but this would add points. If it was 0, it would still add 0 points. But if points is 0, your team's turn plus pluses. That's the last problem. This one. Okay. Get score. Okay, so they set the result right there. And then added whichever team name. And then return result. I did something similar, just chose which team was active, and then returned that line of code. So I think I would have gotten the majority of my points there. Declare at least one private string instance variable and one private int variable, which I didn't do originally, so that would have lost me a point. Constructor, declare the headers correctly. So there's 4 points right there, and you really don't have to do much of anything. You need to make sure you declare your class, and you declare it as something, well, declare it as public. So without there's a lot of little things in here of like ways you can earn a point, and there's a lot of parts to this. But without really any knowledge besides creating the headers and just knowing basics, you can get the first 4. Obviously, that's not the final score you want, but it is something, there's something to be said about being able to kind of scrounge up points wherever you can. Okay? All right, let's take a look at number 3. WordChecker. You have so this will be our array list problem. We should have expectations of looping through an array or an array list and maybe removing values from an array list or adding values from an array to an array list is often what it is. Then you would maybe search through and filter an array list or count the number of times something happens with an array list. So specifically when they have this array list already set up, if I see an array somewhere else, which I don't, but I don't. So it could be just an array list problem. They might not necessarily have an array that you utilize. So it's not always both arrays and array lists. It could be one or the other. Is word chain method, which determines whether each element of word list, except for the first, contains the previous element as a substring. The following table shows 2 examples. So an has band. Band has an in it. Band has band in it. Abandon has band in it. So that's why that's true. Okay. 2 has 2 in it. 2 has stool in it. Tools does not have stool in it. Okay, so I mean, you almost have to use dot contains or dot index of, and I just normally use dot index of in these scenarios. So I guess you would just loop through the array list, comparing values, and they all have to be. So if they all have to be, then you're searching to see if any of them do not. So what is this? Word chain. What is this called? WordChecker. WordChecker.java is what I meant to do last time. So public is word chain. Public Boolean probably is word chain. Yes. We are going to loop through, and could you use an enhanced for loop? I don't see why not. I is less than, the name of the array list is word list. Okay, we'll do it this way, and then do it with an array or enhanced for loop. Dot size I++. So we're looping through our array list. Now, it said even in it, you don't want to start with the first value. You got to remember all of these instructions. And so we're going to be comparing this is going to be a little bit more painful with not using an enhanced for loop. So wordlist.getI will get our string of the ladder of the values, dot index of wordlist.getI -1. So this whole thing is going to check where this is located inside of this. So if it does not exist inside of this, exist inside of this, it would not equal -1. That means we did not find this inside of this. So at that point, if we don't find it in there, we return false. Correct. That if it's not equal to -1, that means you found it at an index of 0, of 2, of 3, of something. I meant to put equals -1. And so that would mean you did not find it. And so that would return false. You would not do, this is the biggest mistake people do. They say else return true. Remember, so don't do this. So remember, if you are looping through and you are checking that all values do something, the biggest mistake is either you are looking for if this is inside of this, return true, else return false, or doing it this way, return false, else return true. Well, that means based off the first two values, right away you're going to return true or return false, and you're not going to analyze any of the other values. So you can't do it like that. You're wanting to loop through and look at all of the values in your word list, and if any of them do not meet the criteria, that is when you can return false. But if they all meet the criteria, then you can return true. The example I give is if I had 10,000 numbers in a list and I told you to tell me if they were all positive, would you be going and looking at every single number and checking that they were positive? Probably not. You would probably be quickly searching through to see if there was a negative value, and then at that point you would return false. So if you're checking if all the values are positive, it's kind of a weird thing where you need to reverse your thinking and actually be checking if any of them are negative, and if none of them are negative, at that point you can return true that they are all positive. And so that's what we're doing here. I think that's good. Just going to go ahead and just say it straight up. I think that is probably something that we can do. Okay, so they created individual strings for each. Sure. Equals equals -1, return false, return true. Okay, exact same idea. Doing it with enhanced for loop might be a little bit easier, but you can't because you are looking at the previous index. So I always just default to doing the traditional for loop because I don't want to have to go back, and it's not much more work to me. So, but that's why you cannot do it that way. So you would have to do the traditional for loop. So on to part B. Part B, create a list. So now we're going to loop through and we're going to create a new array list, or new list, which creates and returns an array list string. The method identifies strings in the word list that start with the target and returns a new array list containing each identified string without the starting occurrence of target. Elements must appear in returned list in the same order as they appear in word list. Okay, consider an example. See, I'm not following this exactly because it's a little bit tricky. So I look at the example and keep looking at the example until it tells me something. And if I can't find it then maybe I'd reread the explanation. But don't get caught rereading the explanation over and over and over again. Just go to the example. Sometimes it's very clear when you just get to the examples here. So we have catch, bobcat, catch a cat, cat, at. The following table shows the array list returned by some calls to the create list. So create list cat. Oh, so we're returning only the values that have cat in them will be added to the list, it looks like. But they will only be added to the list without the original cat in them. So, why isn't cat in there? Start. It has to start with cat, right? Okay. So index of 0, yeah, equals 0, something like that. Begin with cat. See, the explanation very clearly tells me, okay, it begins with cat. So look at the examples, look at the explanations in the examples. Should be pretty straightforward there. So dog doesn't exist in any of them. Catch, only this starts with catch. Well, and this. But yeah, you're only adding the ones that start with. So, all right. The name, probably need to know that. The name of the method is create list, and it is a array list returned. Okay. So public array list string create list. I don't think we pass in. I think we just use the list. I don't think we have to pass in. Yes. Ah, the target. Yeah. So of course the value that we're checking is what's going to be needed. So yeah, I'm adding to another list. I don't think I need to do any enhanced for loops here. I is less than word list dot size I plus plus. If word list dot get I dot index of target equals 0, then we need to, so whenever you see that you're returning an array list, you probably need to add a new array list of your own. So this will definitely be a point, is being able to correctly create this array list. So array list string result list equals new array list string, and they'll show you that you can have little errors in here, and sometimes they don't take off for most of them, as long as you get the idea and you try to initialize it. So result list is going to dot add a string. So the easiest thing to do is word equals, and then I'm actually going to, and I probably should have done this before, but it will be harder if you do this writing. You could repeatedly use wordlist.getI throughout here, but it's a little bit easier if I do this. And I could even, either I could do word.substring target.length. So you want to ignore the number of values in target.length. So if it was cat, that would be 3 letters. So substring 3 would start at index 3 and go to the end, which is exactly what we want. Yeah, you could put this whole thing into its own string right above and then only add in a variable, if that makes more sense. I don't know if I'm missing anything. I'm gonna go with that and see what the answer they have is. Array list, they did use an enhanced for loop. Dot index of target, current dot substring target dot length is what I did. So they did create the new variable before they added that new variable in, where I just put this code, of course, not with an enhanced for loop. So it had the wordlist.getI.substring target.length all inside of the add, which is fine. It's a little long-winded, so it's sometimes good to break up your code into a little bit more manageable pieces. But yeah, still works. Word, I did turn it into a word. Word.substring target.length. Yeah. Okay. All right, number 4. Two-dimensional array of integers where the path is based on the values of elements in the array. When an element of the 2D array is accessed, the first index is used to specify the row, and second index is used to specify the column. The following location class represents a row and column positioned in the 2D array. The row, the column gets stored. Get. Okay, pretty straightforward there. Grid path class contains a 2D array of int values and methods to use to determine a path through the array. You will write 2 methods of the grid path class. Returns location representing a neighbor of the grid element at row column. Row is a valid row and column is a valid column. Okay, let's look at part A. So, get next location, which returns the location object that represents the smaller of the 2 neighbors of the grid element at row column according to the following rules. The 2 neighbors that are considered are the element below the given element and the element to the right of the given element if they exist. If both neighbors exist, the location of the neighbor with the smaller value is returned. The 2 neighbors will always have different values. If the only one neighbor exists, return that neighbor. Okay. I think I get that. All right. Location class. Location.java. Public int get next neighbor or next location or something. Get next location. So we're going to return a location object. Of okay, so we're going to have to loop through the grid. It's already initialized, so we don't have to loop through the grid. But we need to analyze some things before we just access the value. Okay, so we're going to get next location. Okay, so it has an int row and int column. So if row equals, I'm just going to say grid.length. That means you're on the last row. Is it never going to be the bottom right corner? What happens if it's 4, 4? Say that again. Okay, thank you. So that solves our question. So if you are on the bottom row, then you know you won't be on the bottom column. So there's only one value you can return. Return, and do we have to create a new location object? Yes, I would assume so. So this is our location. So new row column. Because this is an array of int values. So we analyze the int values, but we're returning location of row would be the same, column plus 1. If column equals grid at 0 dot length, return new location row plus 1 and column. And then these would be like our other individual. So we've handled the last row, we've handled the last column. So now we need to be comparing values. So if, can we just go straight into it? Row plus 1 column is less than grid row col plus 1. So this is below the location below the original row and column. This is the neighbor to the right. If the neighbor below is less than the neighbor to the right, we are going to return a new location of row plus 1, column stays the same, else return new location row comma col plus 1. Does that track? I feel like it's, I would have to go back and reread it, and I don't necessarily want to do that. Both neighbors exist, smaller value is returned. They'll always have different values. Okay. Below the given element, an element to the right if they exist. Okay. Yeah. So let's take a look at what they said there, what they got for number 4A. Yeah, they did else ifs, but if you're returning the value, it's stopping at that line anyways, so I don't think that's necessary. Did I say just dot length on each of those? Not the last value is obviously the positions start at 0, so I would have needed to stay very diligent and be specific on exactly what I wanted to have happen. Otherwise, you can make silly mistakes like that. So, absolutely, still return the correct values here, but less than, yep, else, yep. So that's exactly what they asked for there. Guards against out of bounds. Boom, missed a point right off. Fail to access any element of the grid in this part as long as you could fail to access any element of the grid as long as the guard prevents the return location from being out of bounds. So, okay. Return a location that would be out of bounds. Okay. That I would have gotten a point. That I would have gotten a point. Okay, now we're into sum path. Okay. Sum path. Right, a sum path method which returns the sum of all the values on a path in the grid. The path begins with the elements at row call and is determined by successive calls to get next location. The path ends when the element in the last row of the last column of the grid is reached. Shaded elements of the grid represent the values on the path. The method call returns 19 because 3 plus 2. Okay, so it gets the smaller, 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 all the way until you reach the bottom right corner. You can assume that your method works correctly. Sum path. Okay. So I bet it's an int value, I guess, sum the path, yeah. So public int sum path, int row, int call. Okay, while row does not equal, and I'm not going to mess this up again, grid length -1, and call does not equal grid at 0 dot length -1, we are going to it includes the first value, so we're going to do a sum that we're going to return, so you obviously need to have that start at 0. Sum plus equals grid at, since these are all int values, grid at row call and then so you have getters in your location methods. So I guess I would probably have location current location equals new location row call, and then I would say cur location equals our get next location method with row and then column. And instead of doing row and column here, I would probably do cur location dot get row so that they could update cur location dot get call. And so those would update each time through. With the get next location, you would add that value in the grid. And then what? Return sum. Probably went too fast and missed something here, but hopefully not. So let's take a look. Sum is 0 while, wait, why is it or? Oh. Yeah, it should be an or. I did an and, didn't I? So this would be if it's on the last row. Oh no, this is if it's not on the last row and it's not on the last column. So if it's on either of those, on the last row or on the last column, I would not be doing it. So yes, it needs to be an or. This is De Morgan's law. Sometimes you need to think both ways, and that helps kind of analyze that by using De Morgan's law of like, well, I could have put not row equal to grid.length and call equal. So if row is on the last row and on the last column, we're good. So what's the opposite of that? I could just use this not operator, or I can think of it that way and then distribute it out and be like, okay, so if I wanted to do it distributed, I would need to do a not, I would need to flip the and to the or, and I would need to do a not there as well. So yeah, another little mistake though, and you guys can see, I mean, even me knowing what I'm doing, but I'm going quick, okay? I have, 24 minutes left, and I'm explaining my answers on the way. No, 34 minutes left. Explaining my answers, so I'd go back and double check myself. You don't want to go too fast. What else? Yeah, you can still get, I mean, I probably still got 33 or 32 points. I think I missed 1 point on each maybe each section of 2. So each of the actual questions, I think I only missed 1 or so. So with little silly mistakes though. So you don't want to have those mistakes and not be able to answer a question. So just be careful with all that. Yeah, the 2D array, I didn't really go over exactly what you can expect on number 4. This is actually a little bit unusual. Usually you talk about row major versus column major order, and you really focus on that. You are comparing values next to each other in like the column before or the column after or the row before or the row after, and really being aware and able to identify where you're at in the 2D array and do certain things with that. A lot of times you will be using objects, and kind of it's a little bit shocking, but could be in the test too, of like mixing a 2D array of ints and utilizing objects with that. That's not all that uncommon with this 2D array problem. And then yeah, it's a little bit of logic going through rows and columns and knowing what to do there. So best of luck. You guys will do great. Let me know if you have any questions, okay?